As we start our third practice of the day, I want you to go to the paper that says free response practice, and on this paper you see a table of values. I'm going to flip back so everybody can see it. It looks like this. Make sure you are on this side, and I want you to draw this. I want you to draw this, okay? So I'm going to do the same, and I'm going to do it in the bottom right-hand corner where I have just a little bit more space, a little more space. If you are not done and you are watching this being played back, please press pause, and we are going to use this. Here's my drawing, and so in my classroom this will be fine. And next to this, please, I want us to write, okay, ready? Down here, I want you to write inflection points. Inflection points, or if you have it up top, that's fine, same thing. Inflection points occur, I got to move this down so everybody can see. Inflection points occur. Oh, I didn't give myself enough room. When we switch concavity. When we go from concave up to concave down, we have an inflection point. Or when we go from concave down to concave up, we have an inflection point. I'm going to show you a picture of this really quickly. Inflection points occur, and this is really going to move into calculus, but inflection points occur when our concavity changes. If I show you just a brief picture, everybody look here. It looks about right here, and we're going to talk about derivatives. You'll talk all about that in calculus. But can you see how if I was able to take a highlighter here, and I wish I had two highlighters of different color, which I don't have, but here's one. I'll make one solid and one. Okay, look at the picture you drew. What is this an example of up to this point? Look at the picture. Look at this picture. And then look down here. Do you guys agree that's decreasing, but it's concave up? Okay, now look. Now, at a certain point, it's still decreasing, but what kind of concavity does it now have? It's still decreasing, but it's going to be concavity down. Okay, so now let's go back up here. Let's look at this right now. The table below shows the function values and graphical properties of a cubic polynomial function. Circle that. Cubic polynomial function. H of x with the indicated values and the intervals of x. For what value does the graph of this function reach a relative maximum? Before I go any further, how do I know right away that cubic functions will have relative maximums and not global? As a group, go. How do I know that cubic functions will have relative maximums but not absolute? Well, let's just draw a really quick picture. What do cubic functions look like? They go up on the right and down on the left. Did you guys agree? And a lot of times they have something like this, correct? So this would be considered like a high point and a low point, but it's not the highest point. Can you tell me on my graph right here, what is the highest point? We can't name one, because what does this arrow mean? Never stops going up. And we can't name the lowest point because it never stops going down. Okay, got it? Okay, so what I want to do is I want to give you 2 minutes. I want you to give 2 minutes, and I want you to take what you're given here using a pencil and do the best you can to draw what you think this looks like. I'm going to press pause, 2 minutes. Hopefully you had a chance, if you're watching this, to try it. Let's do this together. So this is key. I want to look down below and I want to find increasing and concave down. Concave down is here, but this is increasing with concave down. Increasing with concave down. So from negative infinity all the way up to -3, it is concave down. It's making this shape like this. And it goes all the way up to the point where x is -3 and the output, or the y, is +3. So please go to -3, +3, and draw that point. All right, this is my example right here. There's my example on this left-hand side of it's increasing from left to right, and it's concave down, concave down. Looks just like this down below. Now, I still need to decrease as I go to the right. I need to decrease. Okay, I'm going to decrease, and it still needs to be concave down all the way to getting to the point. This is an ordered pair. Please write this ordered pair down if you're confused. There's your input, output. This is your input, this is your output. So it's going to be concave down in a decreasing motion all the way to -1, 1. So what does concave down go? It's making this oops, that was a little too drastic. It's making this motion concave down as it decreases. But once it hits the ordered pair -1, 1, there appears to be an inflection point. How can somebody tell me, why do I know there's an inflection point here? Because the concavity changes. When it goes from concavity of down to up or up to down, when concavity changes, there's an inflection point. So I'm going to draw a little arrow, by the way, here. I'm going to write inflection point. Change of concavity. Okay, so at this point now, I still need to be going down because it says it's going to be decreasing, but it's concave up. So I'm still decreasing, but it's concave up. So it's flipping around like this, okay? And that's going to go all the way to the point 1, -1. So 1, -1. So it's going to now flip, and it's looking like this. Now, after you get to the point 1, -1, it's going to change here, and it's going to be, oops, still concave up, so there's no inflection point. There's no inflection point. There's a turning point because it's changing from increasing to decreasing, but that's different than inflection point. And now it's going to be increasing concave up. Okay, increasing concave up. So it's looking something like this. Based on what we just drew, I'd like you to come up here, and I'd like you to show me where is the relative maximum and where is the relative minimum. And then tell me why you know that's relative and not global. You have right now 45 seconds. Identify an ordered pair that is a relative maximum. That's in part A. Identify a point that is a relative minimum, and tell me, in words, how do you know that they are relatives, maximums, and not global? That's A and C together, guys. That's A and C together, okay? So I know it's a relative maximum because it goes from increasing to decreasing. It creates that turning point. That's a high point. I know this is a low point. It goes from decreasing to increasing. This is low point to relative minimum. Again, why do I know there's no absolute? We talked about that at the very beginning. With a cubic function here, there's going to be no absolute or global max or min because this arrow means it continues to go up and never stops, continues to go down and never stops as well. Okay, let's jump down to the very bottom here. Approximate the x values of the graph. Right? Approximate the x values where an inflection occurs. Inflection is different than turning point. Turning point means it goes from increasing to decreasing. Inflection means concavity changes. Here's where it went from as concave down, oops, concave up. That's right here. What is the x value? The x value is x equals -1. And how do I justify that? The concavity changes. It went from decreasing concave down to decreasing concave up. Those are the words you need for part D. Those are the words you need. How do I know that's the inflection point? When x equals -1, it changes from decreasing concave down to decreasing concave up. Do me a favor right now and flip to the back side. This is the easiest of the four. Flip to the back side. With your arms right now, circle, oh, this should have been the end behavior. Can you please write I forgot the end behavior. With your hands right now, use your hands like the cactus dance. Look at, this is the back side of this. Give me your hands. What does this look like? Go. What does this hand look like? Am I up on the right or down on the right? Down on the right and up on the left. You need to know that, okay? You need to know that. Here's what I'd like you to do for homework. Is everybody looking? I would like you to complete this fourth one. Complete this fourth one for me. Hold on here. And we started off class by looking at this one right here. And I'd like you to do the front and the back side. Oop, did you have a back side to yours? You should have. Did you? You should have started off class today by doing this one and this one. That's what I'd like you to do for homework as well. That should be no more, just giving you a heads up, that should be no more than 15 minutes for you. I will also post a video of me doing this one and doing these two as well, okay?